What I'd like to do is to walk through the answers for the gravity worksheet on Newton's version of Kepler's third law. The basic equation, as we saw, was up here. P squared equals these annoying constants, 4 pi squared divided by the gravitational constant. The sum of the masses of the system is down on the bottom, times the semi-major axis cubed. And you'll remember that what we did was we put in order to make the calculations easier, we put the units of the equation into solar units, into units that relate to the Earth-Sun system. So the sum of the masses is the mass of the Sun plus the mass of the Earth. Remember that this guy is about 1/300,000th of the mass of the Sun. And so we neglect that. So then we have the sum of the masses equals essentially the mass of the Sun. And then the period squared, if that's in years, equals the mass of the Sun divided by the sum of the masses in whatever system you're thinking about, times the semi-major axis, again in astronomical units. So now what we can do is we can go through the three different questions. So if you discover a planet around a distant star, orbiting the star in 2 years at 1 astronomical unit distance, if we assume the planet is much less, planet mass is much less than the star, how massive is the star? And so we'll remember the period in years squared is the mass of the Sun divided by the mass of the star plus the mass of the planet, right? And you'll remember that we set that equal to just the mass of the star because this is negligible. Okay, times the semi-major axis in astronomical units cubed. Oops. Cubed. Okay. So then if we simplify, the period is 2 years, and so period divided by years is 2 squared equals 4. Okay. Equals the mass of the Sun divided by the mass of the star times the semi-major axis, which is 1 astronomical unit, divided by astronomical unit, so then it's just 1. 1 cubed equals, and this just equals, whoops, this 1 cubed just equals 1. So then 4 equals m Sun over m star. If we switch these two around, right, so what you can do is you take the whole equation and you multiply it on both sides by m star, and you divide it on both sides by 4. So we'll do that right here. Four times the mass of the star. I'm going to divide, so remember I'm multiplying both sides by m star, dividing equals m star divided by 4. I'm doing that on both sides of the equation, times m sun divided by m star. Okay, so this cancels out on this side. This cancels out on this side. So I'm scratching that on this side. So then m star equals m sun divided by 4. Okay? So the mass of the star is a quarter the mass of the sun. The next question uses the same equation. A star has 3 times the mass of the sun, and the planet orbits at 3 AU. And so we'll simply use the same equation. P squared equals m sun divided by, remember, m star plus m planet just equals m star, because the planet is such a small fraction of the sun's mass, times a cubed. Now, we know that the mass is 3 times that of the sun, and we know that the planet orbits at 3 astronomical units. And remember, this is in astronomical units, and this is in years. So we have then m sun. Mass of the sun divided by 3 solar masses. Right, so those two cancel out, times 3 cubed, which is a third, times 3 cubed. That 3 goes away into a 2, so that's 3 squared. So p squared equals 3 squared, so period equals 3 years. The last example is very similar, but it's just a little bit more abstract, because here we're thinking about Saturn and a moon Titan. So we're using the equation period in years squared equals the mass of the sun, because remember, we're just referencing this to the orbit of the Earth, so we get rid of these annoying constants, times the mass of the system. This is mass of Saturn plus the mass of Titan. Right? And remember that the mass of Titan is a lot smaller than Saturn, so we simply neglect that. And that equals the semi-major axis in astronomical units cubed. Okay? So then what we have here is 16 divided by 365 squared equals m sun over m Saturn times 0.008 cubed. So plugging this into a calculator, this is 0.044 squared, which is 1.9 times 10 to the minus 3 equals m sun over m Saturn times 0.008 cubed, and that's 5.1 times 10 to the minus 7. Okay, so then I'll do the same kind of trick that I did up here. I need to multiply both sides of the equation by m Saturn, and then I need to divide both sides of the equation by 1.9 times 10 to the minus 3. And so in the end, when I do that, and you can do that part yourselves, m Saturn is 5.1 times 10 to the minus 7 divided by 1.9 times 10 to the minus 3 times m sun, which is 2.7 times 10 to the minus 4 times the mass of the sun.